Hello friends, today I am going to deal with a session in engineering mechanics. So here in this session I will be dealing with principles of mechanics and also the force system. So we will be discussing in detail about what are the principles involved in engineering mechanics and also the force system. So in principles of mechanics, first of all we will see what is mechanics. So mechanics, it is a branch of science which deals with study of forces and their effects on body. It is a it is an extension to the physical science. It is a part of physics where in particular we study about the forces and their effects on any body. So why should we learn this subject of engineering mechanics? So for any engineer, particularly civil or mechanical engineer, we deal with forces and their effects. So when we construct any structure like dams, buildings, all those things, several forces will be acting on them. So we have to know what are the effects on the structure. Similarly, on mechanical components, any shaft, aeroplanes, anything, any object which is subject to any force should be dealt in line with the engineering mechanics. So we have to learn engineering mechanics for designing any structure which is subjected to force. Maybe it may be a ship or an aeroplane or a civil structure or any mechanical structure or boilers, anything, any structure in this world which is subjected to forces should be designed according to the principles of engineering mechanics. So this is very crucial subject in engineering, particularly in civil engineering. The basics of engineering mechanics are very crucial. As we go higher and higher in further study of engineering, we have to learn strength of materials, theory of structures, analysis of structures, and steel structures, hydraulics, all these subjects, the principles are based on engineering mechanics. So if we know in these concepts very well, in our further study, it will be very easy to understand. Once we understand these concepts, the other concepts will be extension of these concepts. So importance of engineering mechanics is its study is important for engineers because to analyze, to design, to predict the behavior after the construction of structural member. So we have to for designing, for analysis, for also for prediction of how the structure behaves after it is constructed, after it is built. We have to know. For that we need the knowledge of engineering mechanics. So classification of mechanics. This mechanics, general mechanics, is classified into three types. That is three classes. One is mechanics of rigid body. That is for rigid bodies we have one set of the formulae and uh, other things. And for mechanics of deformable bodies, mechanics of fluids. These three are the different categories of mechanics. So for we will study separately, their concepts are separate, but basic concepts are related to the mechanics. Only according to the need they are separated as for rigid bodies, for deformable bodies, and for fluids. That is for in the bodies which are fluids, that is air and water or any fluids. For them these concepts are different. Application of engineering mechanics. So where do we apply our knowledge of engineering mechanics? In which areas we use these concepts? So first of all, to solve the engineering problems, all the engineering designs, all the engineering aspects we need the knowledge of engineering mechanics. Planning, designing and construction of machines, in structures, in construction of machines, in from small machinery, small tool, small nail to a big machinery, a big any machinery, a big turbine or aeroplane engine, anything we need these construction or designs. They are based on the engineering mechanics principles. Design of civil structures, analyze forces acting on structures. So if we want to analyze what are the different forces acting on structures and their effects, we have to know the principles of engineering mechanics. So what is the basis for engineering mechanics, how it is built, or as early as I told earlier, that the basic principles are extension of physics. The all the laws which are in physics, they are they are applicable in engineering mechanics, but particularly we confine our study to only the only to the area of engineering. So there are several physical laws, but our aim is to constrict ourselves to an area which is in the engineering gamut. So the basic laws which form the foundation of engineering mechanics are Newton's laws of motion. That is the first law of Newton, the second law of Newton's motion, and the third law. These three laws are important in formulation of engineering mechanics principles. And also gravitational law, parallelogram law of vectors or forces, parallelogram law, generally what we call it as, and law of transmissibility. These laws form the basis of engineering mechanics. So all these laws form the actual basis. From them we emerge the subject of engineering mechanics. So what is a rigid body? We have seen that mechanics of rigid bodies, mechanics of deformable bodies and fluids. So before that, generally we deal with rigid bodies. In our first year engineering mechanics or basic first course of engineering mechanics, we deal with rigid bodies. So therefore, we define what is a rigid body. As the name itself suggests, it is the thing which is rigid, that is which cannot be deformed. So the body which does not deform under the action of applied load. When we apply load, this body remains as it is, that is it doesn't change its shape or size. So those bodies are called rigid bodies. In actuality, there will be very slight deformation which is negligible, so we consider those bodies as rigid bodies. So a ideal rigid body, there won't be any ideal rigid body. Generally bodies will have a slight deformation, very slight deformation on application of very high loads. Even then we consider those bodies to be rigid bodies for our convenience, because we assume that these bodies are rigid. So another classification of engineering mechanics. So classification of mechanics, it is another classification, that depending upon the state of the body, we classify as statics and dynamics. As the name suggests, statics. These bodies are static; they won't move. Those bodies are called static bodies. That study of that area of engineering mechanics which deal with static bodies is called as statics. And similarly, for engineering mechanics, when we apply those principles to the moving bodies, we call it as a dynamics. That subject we call it as dynamics. So statics deals with effect of forces on bodies at rest. When the body is at rest, the forces, when they act, then that study we call it as statics. Similarly, dynamics deals with forces and their effects on bodies in motion. So all the bodies which are in motion, when we apply the principles of mechanics, that that area of study we call it as dynamics. So similarly, the dynamics is further the moving bodies, the effect of forces on moving bodies is further classified into two classes. That is kinematics, which deals with motion due to application of force, and kinetics, it deals with motion without reference to the forces causing it. So we don't, even though they are moving, in kinematics we concentrate on what is the effect of force, and in kinetics we do not bother about the forces causing the motion. So these two are the subclassifications of engineering mechanics. Basic concepts which we need to know in engineering mechanics is space. The space is the position of point, or this concept which deals with where is the point in the space. So we should know the concept of space for dealing for uh, in engineering mechanics. For dealing with the subjects of engineering mechanics, we should know the concept of space. Similarly, time. So from one point of time to another point of time, what is the difference? That to know that effect, we have to know the concept of time. To relate sequence of events. So what is the difference between the first event and second event? That time period, that time gap, we should know. So when the first event occurred and when the second event occurred, so that difference, to know that difference, we need to know the concept of time. Similarly, we should know mass. So mass, as we know, it is the quantity of matter. It is the quantity of matter possessed in a body. So when a body, it is a body consists of particles. So that is we call it as a matter. So mass is the amount of matter contained in a body. The attraction between the body depends on the masses. We know the formula, the Kepler's laws. That is the attraction between two bodies depending on their masses. Similarly, force. So we did, what is a force? Generally, in English language, we have same meanings for many words, but in physics and engineering, we use particular word for particular meaning only. So when we say force, it is an agency which changes or tends to change the state of rest or uniform motion of a body. So it changes the state of a body. An agency or an effect which changes the state of a body. That is, a body state means whether it is in the rest or motion. When the body is at rest, if we move it, then we are changing its state. So what is the agency which is moving the body? That agency we call it as force. So something which is moving a body, that something, that agency, we call it as force. Similarly, when a body is in motion, if we stop it, we call it as we have changed its state from motion to rest. So the agency which is causing to stop the body, which is stopping the body, that agency is nothing but our force. So force is an agency which moves a body or stops a body. That means when the body is moving, it is stopping, it is changing its state. Similarly, when the body is at rest, it is moving the body, so it is changing its state. This agency we call it as force. In physics, in our earlier classes, we might have had a course on system of measurements and units and measurements. Generally, for in the first year physics, we have this chapter of four units and measurements. So, what is a measurement? How do we define a measurement? So, measurement involves comparison of chosen standard or unit of similar kind. So suppose two two things are there. We compare them with some standard unit. So many units for this, so many units for that. So that comparison of unit we call it as measurement. So if I say two hmm, two scales or two 2 inches, 2 fingers of length and 4 fingers of length, this comparison, then my finger becomes a unit, that comparison becomes a measurement. So 2 and 4 is the measurement. So 2 fingers, 4 fingers, or 2 meters, 2 kilograms, all this becomes the measurement. To measure a physical quantity we need, so to measure any physical quantity, whether it is a length or weight or any physical quantity, we need a standard unit which the quantity is measured. A standard unit. So we should have some standard unit to measure any quantity. So earlier there used to be many units for a small measurement. We used to have different units. There would be a confusion and conflict. So a unit should be standardized. So throughout the world the same unit should be followed. Then only the communication will be correct. The number of times the quantity contains in the unit. So these two things we should know, we should have to measure any physical quantity: the standard unit and how many units, the number of units. So it gives how many and what. How many? 4. What? 4 millimeters, 4 centimeters, or 4 kilograms. 4 is the amount and the unit. This completes the measurement. To complete a measurement, we need two things. That is how much and what. What is the unit and how many are the units. So the unit, the measurement, to measure some quantity, any quantity, we have some fixed unit. So how do we define a unit? It is the value of physical quantity in terms of which other quantities of similar kind are expressed. So we make a standard measure and we compare that with other. For every comparison of the same kind, we use that unit. So suppose if I say some meters, so meter will become unit. So 4 meters of width, 4 meters of length. All this comparison is done with respect to the unit called meters of the same kind. We cannot compare the length of the cloth and weight of apples. So there are different kinds. So comparison will be done between the same kind, and that comparison with some standard measurement is called unit. Units are divided into two categories. Units are divided into two categories. That is, there are two types of units. That is, base units and derived units. Base units are units which they do not depend on any other units. They do not depend on other types of units. Suppose a length is there. Length in itself, it is not dependent on time or distance or anything. Time or mass or anything. So length in its own self, if I want to measure any distance, I need only units of length. Similarly for weight, it is not dependent on any other units. Similarly derived units, they depend on other units. So an area depends on two units, that is measurement unit, length unit, and breadth unit. So an area or a square, velocity, distance by time. Velocity is displacement by time. Displacement units and time units